Hi, my name is Denia, and this is my final project for CMSC 206 of Database Management Systems in UPOU. So in my first assignment, I talked about being an avid reader. As an avid reader, I read a lot of books, and sometimes they are in different formats. They could be digital, paperback, hardback, or sometimes audiobooks. So I wanted to have a database to store the book information and store them and categorize them basically into different lists. The list could be a wish list, a reading list, on hold list, dropped list, or a completed list. So in my personal reading list database, I have three entities: book, author, and genre. You have the book attributes here, and one thing to note is the format. Uh, the book format is stored here, whether digital, paperback, hardbound, or audiobook. And you have the book status. Book status basically means, is it a book in my wish list? Is it a book I'm currently reading? Is it a book I've currently on hold? A book I've dropped? Or a completed book? And you have the author attributes, name and gender. And the author writes a book. An author may write more than one book, and a book may be written by many authors. And a book may have multiple genres, but a genre doesn't necessarily mean that it can apply to one book. So to convert this conceptual design into logical design, first is to convert the entities. You have book with book ID, author ID, genre ID, foreign keys for book, author, genre, entities respectively. And we have the relationship representation. So the author writes a book. We have that as a book list. And you have a book has genre relation represented by a genre list. So after normalizing my personal reading list tables, I ended up with author, genre, book list, and genre list to be the same as the original, but my book entity actually became smaller. Now it only has title and rating, and we have other tables now. We have book status, like so, and then you have publication info. And these were all done under the 2N form, 2N normalization form, and the publisher list was produced after the third normalization form. So now we're ready, after logical design phase, we're ready to implement our database. I'm going to be copy pasting the code from Notebook++. Alright, so with SQL. To show in database, we don't have with the current status of the database. So now we want to create a new database called, let's say, My Library. So now we have the My Library database. So we create tables. Oh, oops, forgot. We had to enter the database. And now we create tables. So there. And we insert sample information into the database. Alright, so let's say we select from book. So we have this sample information about this book. So before we update the entries or delete the entries, let's look at some useful commands for searching. we want to view all books in a database. If you notice, these four are commented out. I did that so that the output here will be nice. So we have the sample book information. So now we want to view the books that are in my reading list after 2010. So as you can see, last date access was 2011 and 2013. So another search could be a teens book published in New York in paperback format. So Panic is published by HarperCollins. Children's books published in New York, published in 2014. It's paperback, and its genre is teens. So now we want to find a book with more than 300 pages that is not in completed list, or it's a book that I haven't dropped. So we have Panic. It's in my reading list, both of them, and the pages are over 300. Another search query could be find a highly rated book, which is more than 4.0 rating, belong in a series sorted by highest rating. So there. We have 4.7 and 4.4 rating for these two books. So there goes for my searching, and then you have the update here. No error. There seems to be no error, no warnings. And a delete function as well. Right. Oh. So there you go. That's it for my database. Thank you for watching.